Hello everyone, and welcome to my talk, To Kill a Working Drone. If you're wondering who I am, my name is Nkosi. I'm from a city called Johannesburg in South Africa, and I work for a bespoke software development company known as BBD, started by three revolutionaries. This company builds bespoke software for companies across different verticals, from banking and insurance all the way to education and the NGO sector. At BBD, I work for a special unit known as ATC. We're charged with BBD's research and development functions. We do some specialized consulting, but the most exciting part of my job for me is that we are also responsible for facilitating learning for BBD's 800 plus employees that are situated across different cities all over the world. I also teach. I'm a lecturer at Wits University's Digital Arts Department, teaching students from the Wits School of Art as well as the Wits School of Electrical and Information Engineering. And in the little spare time that I do have, I serve on the board of the Ahmed Kathrada Foundation, as well as the National Department of Arts and Culture's Social Cohesion Advocates Board. That was a mouthful, and I've said a lot. The most important thing for you to know, and I really hope that you're paying attention here, is that my Twitter handle is at nlucky_Nkosi. Please feel free to tweet me and let me know what you think of this talk. I'd like to start with a bit of an embarrassing story. On my way home from a company event, I was sitting in my Uber and I found myself on this website where they sell really cheap things. And these things take forever to arrive, but they're unbelievably cheap. So I ended up there and I ended up buying a whole lot of things that I don't actually need. 3 months later, a delivery arrived at work. And the first thing I thought was, who on earth sent me a drone? This person is awesome. Then I realized that I'm that person. Then I was happy and excited. And then I realized, but wait, I don't actually have a use for a drone. What on earth am I going to do with a drone? A friend of mine walked past and said to me, well, now you have to find something to do with it. Why don't you hack it? So I decided I'm going to hack this drone and fly it in as many different cool ways as possible and see how long it takes before I actually kill and destroy this thing. So the drone that I'll be talking about today, that I'll be using in my demos, is called the Parrot Mambo mini drone. Now it's a tiny drone. It fits in the palm of my hand, and this drone is super cool. It comes with an attachable and detachable camera. It also has extra accessories such as a cannon shooter. So if this were a live talk with an audience, I'd probably fly this in the room and target people that are wearing, let's say, white t-shirts. More importantly, around the same time last year, I attended a talk by a former colleague and a friend of mine, Mike Reza. And Mike asked a fundamentally important question. Mike asked, what should the web do? And while we as developers and people who create for the web need to constantly interrogate this question, the users have already decided. The users want to do everything. The web is fast becoming the main means through which people are interacting with all sorts of technology. And all the things that the web has always been criticized for not being able to do, browsers now have to be able to deliver these things. One of the main things is its offline capabilities. Browsers now can't simply rely on having an internet connectivity. Now, this is particularly important for me because in the African context, access to data is actually quite limited. Only a few people have continuous and seamless access to data. A lot of people rely on mobile data providers who charge exorbitant amounts. So it's still only the elite that can access the internet continuously. And yet we have a mobile cell phone penetration of more than 200% across the continent. This means that when we build for the web, when we build web apps that are going to work in the African context, we need to think about how to make them operate they have to be as offline compatible as possible. Now, mobile browsers, I'm very happy to say this, are coming to the forefront. Modern development of web browsers are really coming up with awesome, awesome, awesome things. And today I'm going to show you the power of the modern browser by flying this drone and hopefully not killing it. With that said, today I'm going to show you 3 ways to kill a perfectly good drone. Since we're talking about the web and we're talking about browsers, it's only fair that at number 3, we bring you JavaScript. Now, when we take a look at this drone uses 2 means of communication. You can either communicate with this drone using Wi-Fi or Bluetooth Low Energy. Now, for this experiment, I decided to focus on Bluetooth Low Energy. When you hear Bluetooth, some of you older people in the room might remember it. A while ago, you all had these things attached to your phones and you pretended to be in serious business meetings all the time. People who are around my age, without exposing myself too much, this was at a time when we just moved from infrared sharing of files and started using Bluetooth. So we were still putting together phones as if we needed them to be close to each other in order to share music and share images, etc. Well, Bluetooth Low Energy is slightly different from your traditional Bluetooth, and it's often marketed as Bluetooth Smart. So it's a form of wireless communication that's designed especially for short-range communication. It's very similar to Wi-Fi in the sense that it allows devices to communicate with each other. However, BLE is meant for situations where battery life is preferred over high data transfer speeds. We can summarize this as three main differences. Power consumption. So businesses can run BLE devices for 4 years without needing to replace the batteries or power source. This means that the applications are fundamentally different. While traditional Bluetooth would be ideal for continuous streaming applications, such as using Bluetooth headsets, such as transferring files from one device to another, BLE is optimized for applications that require short bursts or short transfer of data. Now, this can be splitting up your data into small packets and then sending them, or even things like sending bursts of data that send control commands to a thing such as a drone or such as a smartwatch. And then, while traditional Bluetooth devices could only take up to 7 connections at a time, modern BLEs can take up to 20 connections simultaneously. This is, of course, affected by how these devices are created on each end. But what this means is that we now have the power of Bluetooth straight from the browser. With Web Bluetooth, we can interface with all these other devices around, allowing us to build some really, really, really cool things. So since I decided that I want to fly this drone using browser technology, I did what every web developer does. Go on Google, search and see if anyone has done something similar to what you're trying to do. And lucky for me, eventually, I found someone who had done something similar. Peter on GitHub had done a project in which he controlled a similar drone using Web Bluetooth. So I stripped his main script, which he called Drone V1.2, and rewrote it to use classes, and I added a few more features and then came up with 2 scripts called Drone Control Management and Drone Connection Management and Drone Control. Now, with these 2 scripts added as dependencies to your project, this allows me to control the drone and write code such as this. Simple, readable code that can be shared with ease. Drone.move left, drone move right, flip, move forwards and backwards. Now, if you've worked with JavaScript, you know that this is almost a guaranteed way of crashing your drone. Now with this, I can base my control scheme on any sort of input and really control the drone to my will using just a few lines of JavaScript code. At number 2, mimic other devices. Now, one of the biggest critiques of browsers has always been the fact that they can't tap into the device's core systems, such as the security store, such as drivers, and all of these cool things. But that's all a thing of the past. So the MDN web docs document web APIs that are available in browsers quite well. And particularly the Chrome browser always tries to lead the pack. So on their website, they list these specifications and the different APIs that are available in different browsers quite well. The one API that caught my attention here was something called the generic sensors API. What this API does is that it allows you from the browser to get access to your mobile phone's sensors. This includes your accelerometer, your ambient light sensor, your phone's gyroscope, all things that were previously not available to your browser. To check if the browser that's running your code actually supports this, there's a couple of standard JavaScript ways, of seeing if these features are supported. Now, if you want to create a new instance of your sensor, such as an accelerometer, the code is pretty simple. You simply let your sensor equals a new accelerometer or const, right? And then, but how do we start reading? Again, very accessible code, sensor.start. Can't read forever. We need to stop at some point. Sensor.stop. And then if we want to act or perform actions based on this data coming in, we can simply add an event listener to the reading event and then have a function that will then make use of that data. And so with this, I decided that I'm going to fly the drone using my mobile phone, which means that when I tilt my mobile phone forward, my drone should move forward. When I tilt it back, it should move back, and so on and so forth. Now, another big part of the modern browser's responsibility is to create a good developer experience. And what the Chrome debugger allows you to do is to be able to inspect what your mobile phone is doing. It also allows you to actually forward your port. So for this demo, I ran a local server on my laptop. I ran it on port 5500, and I then forwarded that port to my phone, which means that by connecting a USB device with my phone in USB debugging mode, I could then pass that data between my phone and my laptop in real time. And even cooler, I can then inspect and see what's actually happening on my phone. So as I move my phone, you can see the different readings coming up on the screen to show you the different values that I'm getting. And based on these values, I then created a control scheme for the drone. And this is what this actually looks like. When I put my phone up, the drone goes up, tilted away from me, the drone moves away from me, towards me, the drone will come back towards me as well. Putting it back to the original position will land the drone. And as you can see, it's almost a guaranteed way of destroying not only your drone, but yourself as well. And then at number one, which is probably one of my favorite, no hands. Now, we can start doing really cool things by allowing the browser to tap into and communicate with things outside of the browser sandbox. One of those things is the USB port. Now, I took something called the Leap motion sensor. What it does is through USB, you can connect it to your computer and it models using a specialized camera. It actually models the bones on your hands. And this allows you, if you're building games, to create that sort of 3D sense in that space, to create virtual reality experiences using the player's hands. Now I took this, connected it to a browser, and then decided that I'm going to control the drone without having any peripherals directly connected to my hands. And this is what that looks like. So you can see as I tilt my hand to the right, the drone will follow my movement. Now, because the drone and my hand similarly shaped, yes, I've got drone hands, means that I can do even much more nuanced movements, which I couldn't do with my phone, such as rotating it about the Z-axis, Y-axis, and do all sorts of really cool and fancy things. Now, It's important to note here that the values that I'm reading are simply mapped to different movements, and I had to do all of that on my own. None of this was predefined. This was all simply a matter of testing out what works better, controlling the speed as well. And I almost crashed this into my best friend a couple of times today while recording that demo for you. My favorite, if this were a live crowd, is that having all of these different capabilities allows us to really start playing around with different control schemes. So my favorite demo is to have people fly this drone in real time over Twitter. Since we can't do this since this is now an online conference, when this is streamed, I will be online and I am committing to flying the drone and actually recording it in real time. So how it works is that if you tweet Codeland conf with one of these results during the Q&A session, I will have the drone flying, and based on whichever command gets tweeted the most, the drone will perform that action. One of my interests is human-computer interaction. And the one question I get every single time I've discussed this talk, either as an idea or simply done this talk, the first question that people ask me is why? Why would you go through all this trouble to build all of these really useless things? It's simple. This is how I learn. When I have to learn new technologies, I think of the most ridiculous thing that I can build in order to motivate me. It's weird that I'm motivated by ridiculousness, but it's fun. And by playing, I learn. By building playful experiences, that is how I learn. It has become a core pillar of our industry and our field to continuously learn and continuously develop. And so my parting words to you is that keep playing, because as you play, that's how you learn. Thank you very much.